So we're looking at line of best fit. You might have done this already in a previous year, but you might, this time we're doing it the IB way, which might be a little different to what you're used to. In the past, you probably just looked at the dots and put your ruler in a certain way so that half are above and below and drew a line. Now we're going to be a little bit more specific, okay? So some data points, as we know, do not lie in a perfect straight line. To help us make predictions for future results or in between values that we actually have, we can draw a line of best fit. So we draw a line of best fit connecting variables x and y as follows. So look at this. We calculate the mean of the x values and the mean of the y values. So as you can see there, the mean of x is x with a bar with a line on top. Have you seen that before? And then the mean of y is y with a line on top. So girls, what do I mean by that? So in this diagram, say for instance, this point here, that's got 10, 15. And that point there, let's say, is about 16 and let's say, 23. So when finding the mean of x, you would add up all the x values, such as the 10 from here and the 16 from there, plus ... So you're getting all just the x coordinates from each point. Does that make sense? And divided by the number of x coordinates. So here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 coordinates. And then for the y, the mean y value, you add up the y values of each coordinate. So 15, then 23, and so forth. And then add up all those, and then divide it by 12. Now also we can get the calculator to do it for us, like in a paper too. And we'll go through that in a second. But is everything making sense so far? So that's how to find the mean x and y values. Then, once you get the values, let's say, like for instance in this one, I think x and the mean for the x ended up being 15. And the mean for the y ended up being about 29 or something. Then they mark the mean point, or plot it, might be a better word. So that there ended up being their mean point. Everything making sense? So they plotted a new point that was their mean point. It's not impossible that your mean point ends up lying on top of another point. Not impossible. Rare, but not impossible. Then, now, read this carefully. Draw a straight line through this mean point, but that also follows the trend of data. So this means there are the same number of points above and below the line. Now, sometimes if there's an odd number of points, you might have it differ by 1. Girls, technically, a line like this might have the same number of points above and below it, but that doesn't really follow the trend, does it? So see how the red one is better? You want to generally follow the trend of generally all the points and also have the same number of points above and below it. If you can go through some points as well, great. But maybe you can't, up to you. Okay, now, so let's have a go. 10 students had their heights and weights recorded in the table below, and now let's draw a scatter plot. Wait a minute, I've got height and weight on my axes. I don't have any scale. Take a moment. Just for height, what do you think we should go up by, given the graph we have and everything? Just 1, I think so. We only go to 150 to 160. We can just do 1. Okay, so now, has anyone ever seen, especially in the IB, this is quite popular, where, because I'm going to start at, I think, 150 here. Has anyone seen this sort of thing? Where they go zigzag at the beginning? It's because they're skipping values, isn't it? Yeah. So anyway, it's not the end of the world if you don't do that. So just so you know. So I'll just go up by ones. 1, 2, 3, 4, 5, 6. Yep. I think that's a good idea. 151, 152. And now, what would you do on the weight axes? What would you go up by? Can we do 1 again? Yeah, we can. You could even technically skip 1 each time, but it's completely up to you, girls. So, and it's up to you. Do you want to start at 54 or 50? What are your thoughts? You tell me what to do. Sorry? 54? Sure. Completely up to you. You might do a little other zigzag. Yeah. So 150 and 54 right there. So there's my first point, little black dot, and then go for it. Now girls, just based on what we did last lesson, which was the correlation coefficient, remember R? What can you tell me about R based on that, even if you want to guess a value? Yeah, moderate to weak, and positive value because it's trending upwards. And so I'd guess, I don't know, 0.4, 0.5 or something around that, I don't know. Does that make sense? Cool. Okay, now, construct a line of best fit. Now, to do that, we used to just be able to draw it straight away, but to do that, we actually need to find the mean x and y. Now, girls, you absolutely can add up all those and divide by how many? 10? The mean for x is, what was it, girls? Thank you. And the mean for y was 59.8. So that means our line of best fit needs to go through the point 154.1, 59.8, and we can only really approximate that on our graph. Is everyone cool so far? So I might draw that. It's about there-ish. What do you think? That's where I put that cross. It's a little bit small. It's about there-ish. Okay, so I want my line of best fit to go through that point, and but I also want approximately the same number of points either side. Oops, should have done it in a different color. Okay, make it as long as possible. So that's my line. Yours might be a bit different. So tell me, girls, just look at my line for a second. Does that roughly follow the trend, do you think? Are you happy with that? Now, actually, I don't know. Does it have the same 1, 2, 3, 4, 5? I think it does have the same on the side. Now, girls, that is not the only correct answer. Yours might be slightly off either way, but not very off, because I think then it would not follow the trend anymore. Find the equation of the line of best fit. Just looking at my line, can you see 2 points that it looks like it goes through the corner? Do you know what I mean? Like, for instance, I think, sorry? 151 and it looks like it hits that line there, that point there. Do you agree? Can you see another one? 156 and 61. Not quite. No, it's in between. 157 and 63, or actually, yeah, and 159, and I guess that would be 65 there. But I'm going to go with one you said. What would you say? 157 and 63, 158 and 64. Yeah, that's nice too. I'm going to write down the 2 points I'm going to use. So I'm going to use 151, 56 and 8 and 64. Okay, so using your 2 points, can you help me, girls? How do I find the gradient x so that there is the gradient formula? First we label the first point x1, y1, then x2, y2. That's the formula. You sub them in. y2 take away y1 over x2 take away x1. And I got 8 on 7. The point gradient formula, it looks like this. Y minus y1 equals m times x take away x1. So what we do is we use either one of our points. We don't even have to use the x1, y1. We can use x2, y2. But for consistency, I'm just going to use x1, y1. Is that okay? So I go y minus y1, which is 56, equals the gradient 8 on 7 times x minus x1, which is 151. The fact that I've got a fraction gradient is a bit annoying. What can I do to get rid of the fraction? To both sides of the equation. Multiply by 7, yes. So watch this. Watch this. I multiply everything on this side by 7. But then, because these two things are multiplied by each other, it's like it's one big term. So if I multiply this side by 7, what actually happens? It cancels out with the 7 down here. Look. This 7 and this 7 cancel out on that side. Okay, that's very important algebra. And so what do I end up getting in my next line? Can anyone help me?
7 bracket y minus 56.
Yep, what is 7 times 56?
392.
392, beautiful. What happens on the other side? 8x. It's a big one. 1208. Beautiful. All right, we're almost there, girls, don't worry. Girls, does anyone remember the general form of a line? General form of a line is ax plus by plus c equals 0, where a, b, and c are all integers. A should be positive, the coefficient of x should be positive, and they should have no common factors. So girls, what I'm saying here is, I want to bring these onto that side of the equation because I like my 8x being positive. Does that ring a bell? So to do that, you might minus 7y to both sides. So like minus 7y, minus 7y. I'll just do one thing at a time. You get negative 392 equals 8x minus 7y minus 1208. Then what do I want to do to move the 392 over? Plus it because it's negative. So I get 8x minus 7y. Can someone find negative 1208 plus 392? Negative 816. Beautiful. And all of that equals 0, and we are finished. That is the line of best fit. So, describe the relationship between the student's heights and weight. What did you say it was? Positive? Moderate to weak, or weak to moderate? So there is a weak to moderate positive relationship between the student's heights and weight. The numbers in our equation are right, but something is wrong. X and Y, they're not the variables we should be using. What should we be using? W and H. Now keeping in mind, and it helps with the diagram, H is like the X, W is like the Y. So let's now replace X with H and Y with W. So the actual line is this, 8H, is that right? I've just forgotten already. Minus 7W minus 816 equals 0. Now, girls, use your line to estimate the weight of a person 162 centimeters tall. The fact that it said the line tells me I should go back to my graph and use that. But if they had said the equation, I would then use the equation. Okay? Either way, let's maybe consider both. So first, let's go up to the line, and we want a person that's 162 centimeters tall. Okay, well, my H-axis only went up to 160, so I better put in a couple extra. 161, 162. So, here's 162. How do I estimate it, girls? How should I move? What do I do? Go up? So follow that line up. Up. There it is. To me, there it is. Yours might be slightly different, and that's okay. So then I end up about here. I better extend my W-axis as well. I'm between 68 and 69. I'm closer to 69. So I might estimate, 68.7 or something. I think either way around that is a good estimate. But that's for me. Yours might be different. So I'm going to estimate the weight is 68.7, what is it, kilograms? Now, can we take a moment and use our equation as well? So now I'm going to copy down my equation, and I know your equation is slightly different. And where do I put the 162? For H, yes. So it becomes 8 times 162 minus 7W minus 816 equals 0. And then basically I'm solving for W. Beautiful. Okay, so I'm going to keep going with mine. I got about 68.6. It looks like my prediction was pretty good.